I know that you know the unit circle. So if you have the unit circle memorized, then life is good for you in calculus because you'll need that just like you need addition, subtraction, multiplication, division facts for arithmetic. So if you have a way to memorize the unit circle and you have that done on your own, no big deal. I'm going to show you my thinking on the unit circle, and this may be necessary for you. It may not. So the first thing you have to know for calculus is we're not going to use degrees, we're going to use radians. So with this unit circle, I'm going to think of this as the origin, and this is going to be kind of our starting point. And we're going to think of taking a lap around the circle in this direction, and we're only going to concern ourselves with famous stopping points. So I'm going to put these stopping points on the unit circle. And this is probably not going to be drawn perfectly to scale, so we'll just have to deal with that. My very first stopping point would be about right here, which would be pi over 6. Now, if you love degrees, which you can't love degrees in calculus, that would be 30 degrees. Then we would have pi over 4 and pi over 3. And then up here, we would have pi over 2. All right, those are the famous stopping points in that quadrant. I'm going to pause this and fill out the rest of these so that you don't have to be bored by me doing this. So these are the famous stopping points around the unit circle. I definitely did not draw them to scale. They're not in the exact locations, but these are the ones that you would need. They don't seem to focus. I'm trying to focus it a little better. These are the ones that you have to have memorized. A couple things to point out to you that will help. You see, for example, this is pi over 6, but that could also be written as pi over 6 plus another lap around the unit circle, which would be equivalent to 2 pi. So that pi over 6 is really a pi over 6 plus a 2 pi if you wanted. So if I would add the 2 pi to pi over 6 can also be thought of as 13 pi over 6, meaning that location on the unit circle is pi over 6, and if I take another lap around, I'm now at 13 pi over 6. Another thing to think about is this location right here, which is 7 pi over 4, which means I've gone 7 pi over 4 around the unit circle, could also be the same location as negative pi over 4. So if I chose to travel in the negative direction around the unit circle, I would only have to go pi over 4 distance to get there. So, boom, negative pi over 4. So knowing all of these spots, and by the way, that would be 0 or 2 pi, knowing all these spots on the unit circle is the first thing that you have to do, because you're going to have to be able to answer things like at some point, hey, what is the sine of 5 pi over 3? And to answer the sine of 5 pi over 3, you're going to have to know where it is on the unit circle. Step 1, memorize those spots. Once you've memorized all those famous stopping locations, then the next thing you have to memorize is the cosine and the sine value for each of those locations. So in this one's drawn to scale. At 60 degrees, which would be naughty, you can't say 60 degrees. You would have to say pi over 3. So at pi over 3, my cosine is 1/2. My sine is square root of 3 over 2. The way I like to think about it is this. Traditionally, x comma y in the unit circle memorizing is replaced with cosine comma sine, meaning your x thinking in algebra was always left and right. Your y thinking was always up and down. Now your cosine is going to be left and right, and your sine is going to be up and down. So that may have thrown you for a loop, so let me explain how I think about that. To get to pi over 3 on the unit circle, I always have to start from this origin, and I travel, in this case, to the right a certain distance, and then when I've gone far enough, I now travel upwards a certain distance. This travel to the right is my cosine distance. This travel upwards is my sine distance. I'm just following this convention from up here. And then as a helpful tip for me to memorize things, I always ask myself, hey, was that cosine trip a short trip, a long trip, or a medium trip? Okay, so now admittedly that's a little weird, so let me show you what I'm talking about. In this one that's not drawn to scale, it's a little exaggerated to help you think about this. If I want to get to pi over 3, I do this short trip of my cosine and a long trip up for my sine. Whereas if I wanted to get over here to 11 pi over 6, I would have a very long trip for my cosine and a very short trip for my sine. And if I wanted to get over here, I would have what I call a medium trip for my cosine and a medium trip for my sine. So if I think about all these locations around the unit circle, to get to any one of those locations, I'm either going to take a long trip or a short trip, a long trip or a short trip, or maybe a medium trip. So I admit that that's kind of a weird way to think about it. So if that doesn't work for you, then just go with memorization. But that's the way I think about it. And then what I end up doing is I say every short trip is worth a 1/2. A medium trip is worth this, and a long trip is worth this. So to get to pi over 3, my cosine trip was a short trip, my sine trip was a long trip, short trip's value, long trip's value. To get over here, to get over here, which is 5 pi over 4, I would have done a medium trip for my cosine in the negative direction and a medium trip downward for my sine, which is a negative direction. Thus I have negative medium trip, negative medium trip. So by using this convention, and especially if I think about it drawn in an exaggerated way so I can really see my short trips and long trips, that's how I memorize all of these values. And of course, any value that's basically at an axis is easy to memorize because it's one of your coordinates, either a 0, a 1, or a -1. So that's the system I use to memorize the unit circle. As I've mentioned probably too many times, you use whatever system that works for you. What I'm now going to show you is a nifty little add-on to show you how the unit circle relates to the trigonometry you already know. Here I have a t-chart, and for this example I'm just going to use the cosine values. And I've gone through the unit circle, and at every famous stopping point along the way, and I stopped at 7 pi over 6, I put down the cosine value from the unit circle. What I'm now going to do is I'm going to take those y values and start plotting them on a coordinate grid. That's going to be boring to watch, so I'm going to do that here. I'll show you a couple of them. At theta of 0, my cosine value is 1. When I'm at pi over 6, my cosine value is square root of 3 over 2, which, if you're a fan of decimals, is 0.866. This one would be 0.707. And so far I've plotted these 4 points on there. I'm going to pause this while I finish it. As you would expect, as I plot all the cosine values associated with these very famous stopping points, I get the cosine function. So the unit circle is just a nifty way for you to memorize the y values of the cosine function. This thing in your brain replaces that thing. However you can go ahead and get these things memorized, and most people would prefer that system to this system, you go ahead and do it. I hope you enjoyed your unit circle introduction or review.